Okay, so today's video is going to be going through Article 215 as well as 225 and 230. Let me double check. Did we go over anything in 240? I don't think we did. Let me just double check. No. Okay, so 215, 225, 230. So, starting out, feeders. This article covers the installation requirements, overcurrent protection requirements, minimum size and capacity of conductors for feeders, not over 1,000 volts AC or 15,000 volts DC nominal. Okay. Minimum rating and size. Feeder conductors shall have a capacity not less than the larger of 215.2A1 or A2 and shall comply with 110.14C. Okay. So A1, if it supplies continuous load, it has to be 125% of that continuous load. And then 2, minimum feeder conductor size shall have a capacity not less than the maximum load to be served after the application of any adjustment or correction factors in accordance with 310.14. Now, 310.14. Let me just double check that there's nothing important there because it does say. Yes, okay. So 310.14 is speaking on specifically like what size wire you use for services and feeders. So, for example, if you have a 200 amp service, you use a 2-watt copper. So, talking about that, you got to make sure that you use the right size wire for the right size feeder, especially in accordance with that one code article. Grounded conductors. The size of the feeder circuit grounded conductor should not be smaller than the equipment grounded conductor size required by 250.122, except that 250.122F shall not apply where the grounded conductors are run in parallel. Okay, so 250.122, minimum size equipment grounded conductors for grounding raceway and equipment, is talking about how large or how small in this case your equipment grounding conductor needs to be based up to how large of an amperage you're dealing with. So obviously, if you're dealing with 15 amps, it needs to be at least 14 gauge. 20 amps is 12 gauge, and then it jumps all the way up to 60 amps for 10 gauge. So that means anything greater than 20 but less than 60 needs to be run with a 10 gauge neutral, specifically copper. Obviously, copper. Additional minimum size shall be specified to 215.2C under the stipulations, or under the conditions stipulated. Okay. Feeders with common neutral conductor. Feeders with common neutral conductor up to 3 sets of 3-wire feeders or 2 sets of 4 and 5-wire feeders shall be permitted to utilize a common neutral. In a metal raceway or enclosure, all conductors of all feeders using a common neutral conductor shall be enclosed within the same raceway or enclosure as specified or as required in 300.20. Okay. Ungrounded conductors tapped from grounded systems. 2-wire DC circuits and AC circuits of 2 or more ungrounded conductors shall be permitted to be tapped from the ungrounded conductors of circuits having a grounded neutral conductor. Switch. No, sorry. Switching devices in each tap circuit shall have a pole in each ungrounded conductor. 215.9, feeders shall be permitted to be protected by a listed ground fault circuit interrupter installed in a readily accessible location in lieu of the provisions for such interrupters as specified in 210.8 and 590.6a. 215.10, each feeder disconnect rated 1,000 amps or more installed on solidly grounded Y electrical systems of more than 150 volts to ground but not exceeding 1,000 volts phase to phase should be provided with ground fault protection of equipment in accordance with 230.95. Okay. 215.12, identification for feeders. Grounded conductor of a feeder, if insulator, shall be identified in accordance with 200.6. The equipment grounded conductor should be identified in accordance with 250.119. Ungrounded conductors shall be identified in accordance with 215.12C1 or C2 as applicable. Feeders supplied from more than one nominal voltage system, where the premises wiring system has feeders supplied from more than one nominal voltage system. Each ungrounded conductor of a feeder shall be identified by phase or line and system at all termination, connection, and splice points, compliance with 215.2.12 C1A and C1B. So, means of identification is permitted by a different color coding. Posting of identification means the method utilized for conductors originating from each feeder, panel board, a similar feeder document. So essentially, document which feeder or which color ungrounded conductor is what. All right. Then we skip to the next page, and we get 215.18 Surge Protection. A surge protection device where a feeder supplies any of the following, a surge protective device shall be installed. Dwelling units, dormitory units, guest rooms and guest suites, areas of nursing homes and limited care facilities. Location. The SPD shall be installed in or adjacent to the distribution component connected to the load side of the feeder that contains branch circuit overcurrent protection devices that supply the location specified in 215.18a. The SPD shall be Type 1 or Type 2. Where the distribution equipment supplied by the feeder is placed, all the requirements of the section shall apply, and then SPDs shall have a nominal discharge current rating of not less than 10 kA. So, what all does that mean? You need to have a surge protection device connected to the load side of your feeder, so basically the downstream of your electrical setup. And you have to have it protect the specified location. So dwelling units, basically, it has to protect your house. Type, yeah, there's different types of them, I'm assuming. Replacement, it's essentially saying if you update or if you replace or perform maintenance enough to replace on a panel board or a service or a feeder or anything, that you need to update it to be in compliance with this section. And then ratings, 10 kiloamps or kiloamps. It's, yeah, pretty standard. That's it for overcurrent protection. We're skipping over to 225. 225 and 230 are obviously pretty similar chapters, so we'll go over 225 in depth, and 230 will probably be a little faster, but it's how we roll. First thing for 225, conductor size and support, overhead spans. Open individual conductors shall not be smaller than 10 gauge copper or 8 gauge aluminum for spans up to 50 feet in length, and 8 gauge copper or 6 gauge aluminum for a longer span unless supported by a messenger wire. So if you're going to use a large wire, you need to support it. Festoon lighting. Overhead conductors for festoon lighting shall not be smaller than 12 gauge unless the conductors are supported by messenger wires. In all spans exceeding 40 feet, the conductor shall be supported by messenger wire. Okay. Again, support your wires. Don't know why that was so specific to just festoon lighting, but, I'm not the one who writes the code. Attachment to buildings. The point of attachment to a building shall be in accordance with 230.26. 26, yeah. Means of attachment. The means of attachment to a building shall be in accordance with 230.27. So, we'll get into that a little later. Massive support. Only feeder or branch circuit conductor specified within this section shall be permitted to be attached to the feeder or the branch circuit mast. Mast used for the support of the final spans of feeders or branch circuit shall be installed in accordance with 225.17a and b. Scrolling up. A. Strength. The mast shall have adequate strength or be supported by braces or guide wires to safely withstand the strain imposed by the overhead feeder or branch circuit conductors. Hubs intended for use with the conduit serving as a mast for support or feeder branch circuit conductors shall be identified for use with the mast. Attachment. Feeder and or branch circuit conduction or conductors shall not be attached to a mast where the connection is between a weatherhead or the end of the conduit and a coupling where the coupling is located above the last point of securement to the building or other structure, or the coupling is located above the building or other structure. Okay, so what does that mean? It means you need to provide proper attachment and support for your for your branch circuits and feeders, especially when using a mast as a support. Pretty simple. Clearance for overhead conductors and cables, 10 foot above finished grade, where not exceeding 150 volts and accessible to pedestrians only. 12 foot over residential property, and driveways, and those commercial areas not subject to truck traffic where voltage not to 300 volts to ground. So 12 feet is what you're mostly going to see on, like, say you're in a town that has overhead service for some reason. That's usually what you're going to see. 15 feet for those areas listed in the 12-foot classification where the voltage exceeds 300 volts to ground. Pretty rare. 18 feet over public streets, rail alleys, roads, parking areas subject to truck traffic, driveways, or other resistant residential property, and other land traversed by vehicles, such as cultivated grazing forest and orchard. So basically, 18 foot in anywhere that you're going to see truck traffic, which I'm assuming in this case they're meaning like semi truck traffic or tractors. So, for example, 18 foot of space in like farm properties is where you're most commonly going to see overhead feeders anyways. And then 24 and a half foot over track rails of railroads. So 24 and a half above railroads. Next section, A, above roofs. Overhead spans of open conductors and open multi-conductor cable shall have vertical clearance of not less than 8.5 foot above the road surface. The vertical clearance above the roof shall be maintained for a distance not less than 3 feet in all directions from the edge of the roof. Okay. Skipping over a little bit to part D. Final spans of feeders or branch circuits shall comply with 225.19 D1, D2, and D3. Clearance from windows, final spans to building they supply or which they are fed should be permitted to be attached to the building, but not less than 3 feet from windows that are designed to be open. All right. We do have the exception there highlighted. Conductors run above the top level of a window shall be permitted to be less than 3 foot. So I'm assuming, like, if there's a piece of roof in between where the conductor would be anyways and the window, you can put it within that 3 feet. But not sure on that. That's my understanding. Vertical clearance. Vertical clearance of final spans above or within 3 feet measured horizontally of platforms, projections, or surfaces that will permit personal contact should be maintained in accordance with 225.18. Yeah. Building openings. The overhead branch and feeder conductors shall not be installed beneath openings through which materials may be moved, such as openings in a farm or commercial building. These shall not be installed where they obstruct entrance to these buildings. Now, for this one, I'm going to add a little bit of a visual guide because I'm going to tell a little story here. So, my family used to live on a farm out by Morris, Iowa, which is like, you go to like Orange City, and then you go like way far out, and then you get to Morris. So, and on that farm, we had pigs. And one of those pig buildings was a nursery. And that nursery had a hay loft. Now, this is where they used to keep like big things of hay. For what? Not necessarily sure. But as kids, we would like use it as like a little storage room for like, you know, just random assorted shit. Like my sister had a bunny that she kept up there. Essentially, what this is saying is, for something like this, you cannot have your overhead feeder come down here. It has to go up here. So it's pretty simple. I just felt like adding a visual guide and telling a bit of the story. There we go. That's a lot bigger. That's good. Okay. Skipping over to the second part of this page. Raceway sealed. When a raceway enters building or structure from outside, it should be sealed in accordance with 300.5G and 300.7A. Yeah, make sure when you enter a building with a raceway, you need to seal it to make sure that moisture doesn't get in. 225.30, number of supplies, a building or other structure that is served by a branch, circuit, or feeder on the load side of a service disconnecting means should be supplied by only one feeder or branch circuit unless permitted by 225.30A through F. For the purpose of the section, a multi-wire branch circuit shall be considered a single circuit. Special okay. Oh, that's probably important. I forgot to flip the page. Okay, so the final spans part is over here, which we were talking about earlier, which is, yeah, like this 3 part is where I talked about haylofts. Raceway steel is up here, and then number of supplies is right here. Pull further down, A, special conditions, additional feeders branch circuits, god damn it, shall be permitted to supply the following: fire pumps, emergency systems, legally required standby systems, optional standby systems, parallel power production systems, systems designed for connection to multiple sources of supply for the purpose of enhanced reliability, electric vehicle power transfer systems listed, labeled, and identified for more than a single branch circuit or feeder, docking facilities, and piers. So, yeah, I mean, these are going to be stuff that if you're working with them, it's going to be obvious you need to provide extra power to them. So, on to the next page. Disconnecting means. Means should be provided for disconnecting all ungrounded conductors. Why is it keep fucking doing this? Ungrounded conductors that supply or pass through the building or structure. Location. The disconnecting means shall be installed either inside or outside of the building or structure served, or where the conductors pass through the building or structure. The disconnecting means should be at a point readily accessible, or it should be at a readily accessible location nearest the point of entrance of the conductors. So, where your conductors enter your panel, you need to have that readily accessible. Okay. God damn it. Did that again. Alright. Maximum number of disconnects. The disconnecting means for each supply permitted by 225.30 shall not consist of not more than 6 switches. Yeah, we've talked about this in class. Grouping of disconnects. Each 2 to 6 disconnects as permitted in 225.33 shall be grouped. Each disconnect shall be marked to indicate the load served. Okay. The one or more additional disconnecting means for fire pumps or for emergency legally required standby or optional standby system permitted by 225.30 should be installed sufficiently remote from the 1 to 6 disconnecting means for normal supply to minimize the possibility of simultaneous interruption of supply. So if you have a disconnecting means specifically for an emergency system, it has to be kept away from your regular disconnecting means. Access to occupants. In a multiple occupancy building, each occupant shall have access to the occupant's supplied disconnecting means. So, for example, in your dorms, you usually have a sub panel. Types of disconnecting means. The disconnecting means specified in 225.31 should be a circuit breaker, molded case switch, general use switch, snap switch, or other approved means. Okay. Identification where a building or structure has any combination of feeders, branch circuits, or services passing through it or supplying it. Permanent plaque or directory shall be installed at each feeder and branch circuit disconnect location denoting all other services, feeders, or branch circuits supplying that building or structure or passing through that building or structure and the area served by each. Then disconnect construction. Disconnecting means should meet the requirements of 225.38A through D. A, manually power operable. Disconnecting means shall either be manually operable or a power operable switch or circuit breaker, provided it can also be opened by hand. So what does that mean? It means that you either need to be able to manually use the disconnecting means, like an arm on a pull switch or just a simple circuit breaker, or if it's going to be automatically controlled, it needs to also have a manual means of disconnect. So for example, a ground fault circuit interrupter breaker follows this rule because it has an automatic means of disconnect, but you can still disconnect it on your own terms. Next part up here is indicating the building or structure disconnecting means shall plainly indicate whether it is open or closed position. Pretty obvious. Rating of disconnect. One circuit installation for installation to supply only limited loads of single branch circuit. The branch circuit disconnect means shall have a rating of not less than 15 amps. So any singular plug needs to have a 15 amp circuit because it's only a singular thing. For installations consisting of not more than 2 wire branch circuits, feeder or branch circuit disconnect means shall have a rating of not less than 30 amps. So technically you could have a 30 amp small appliance branch circuit, but you're not going to do that because it's kind of impractical. One family dwelling. For one family dwelling, the feeder disconnecting means shall have a rating of not less than 100 amps, 3 wires, so 2 hots and a neutral. And for all other installations, the feeder or branch circuit disconnecting means shall have a rating of not less than 60 amps. Access to overcurrent protected devices. Where feeder overcurrent device is not readily accessible, branch circuit overcurrent devices shall be installed on the load side, shall be mounted in a readily accessible location, and shall be of a lower amp rating than the feeder overcurrent device. Emergency disconnects. For 1 and 2 family dwelling units, an emergency disconnect means shall be installed. Location. Disconnecting means shall be installed in a readily accessible outdoor location on or within sight of the dwelling unit. Disconnecting means should have a short circuit current rating equal to or greater than the available fault current. For 1 or more disconnecting means is provided, they shall be grouped. And then back up here. Surge protection. Surge protective device where a feeder supplies any of the following, and SBU shall be installed. Dwelling, dorms, guest rooms, and areas of nursing homes. Already went over that. So, yeah. Going kind of fast here because a lot of this is kind of obvious, especially now that we get into 230. A lot of this is going to be repeated. But 230.2, number of services. A building or other structure shall be supplied by only one service unless permitted in 230.2a through D. Yeah, I mean, it's pretty obvious. Like a standard house, you're only going to have one main service. And you'll have like feeders from beyond there, unless it's a very specific building, which is listed, such as fire pumps, emergency systems, etc. Already went over that. Whatever. 230.3, one building or other structure not to be supplied through another. Service conductors supplying a building or other structure shall not pass through the interior of another building or other structure. Don't pull your service wires through a secondary building. That's kind of a dumb idea. Conductors considered outside the building. This one was on the test, and I feel like it may have gotten 1 or 2 people, but I'm not sure. It didn't get me, so, but I'm just going to go over it because I know it was on the test. Conductors shall be considered outside of a building or other structure under any of the following conditions. Were installed under not less than 2 inches of concrete beneath the building or other structure. 2 inches is highlighted. Were installed within a raceway or structures or were installed in the building or other structure in a raceway that is encased in concrete or brick, or in concrete or brick not less than 2 inches thick. So it's about the thickness of the concrete that it's encased in, not just the fact that it's in a raceway. All right. Other conductors. Circuit conductors other than service conductors shall not be installed in the same raceway, cable, handhole enclosure, underground boxes, service conductors. Raceway seal where service raceway enters a building or structure. It shall be sealed in accordance with 300.5G and 300.7A. Spare unused raceways shall be sealed. Went over this already. Clearances of buildings, same thing as the other one. 3 foot above a window, exception if the window, the exception that we already went over. Vertical clearance, 3 feet measured horizontally of platforms, objects, or surfaces that permit personal contact. Building openings shall not be installed beneath building openings. Again, the hayloft. Vegetation as support. Do not use trees to support your service. Yeah. Minimum size. Minimum conductors should not be smaller than 8 gauge copper, 6 gauge aluminum. Clearances. Overhead service conductors shall not be readily accessible and shall comply with 230.27A through E. Above roofs. Conductors shall have vertical clearance of not less than 8.5 foot above the roof surface. The vertical clearance above the roof surface shall be maintained for a distance of not less than 3 feet in all directions from the edge of the roof. Okay. Vertical clearance for overhead service conductors. Overhead service conductors, where not in excess of 1,000 volts nominal, shall have the following minimum clearance from each grade. 10 foot where there is no significant truck traffic or generally not accessible. 12 foot over residential with no truck traffic under 300, 15 for if it's 12 but it is 300, 18 for truck traffic, 24.5 for trains. 26, point of attachment. The point of attachment of the overhead service conductor to a building or other structure shall provide the minimum clearances as specified in 230.9 and 230.24. In no case shall this point of attachment be less than 10 foot above finished grade. Service mast to support. Only power service drop or overhead service conductors shall be permitted to be attached to a service mast. Yeah, we went over this. Strength. Service mast shall be of adequate strength or be supported by braces or guy wires. Attachment service strap or overhead service conductors shall not be attached to a service mast to an supports over building. Service conductors passing over a roof shall be securely supported by substantial structures. Okay. Again, we've already went over most of this in the previous article, so now we're getting the stuff that we haven't gone over, which is underground. So 230.30, underground service conductors shall be insulated for the applied voltage. Wiring methods, the 3 that we have highlighted are RMC, IMC, and PMC conduit. PMC PVC conduit. Size and capacity. Conductor shall not be smaller than 8 gauge copper, 6 gauge aluminum. Protection against damage. Underground service conductors shall be protected against damage in accordance with 300.5. Splice conductors. This again, I think might be something that got people on the test about the splice conductors. So that's also something important. Installation of service entrance conductors entering or on the exterior of buildings or other structures shall be insulated. You don't want your wires sticking out. Minimum size and capacity. Service entrance conductors shall have an capacity of not less than the maximum load to be served. Continuous and non-continuous loads. Non-continuous loads plus 125% of continuous loads. Pretty standard. I went over that previously. Spliced and tapped conductors. This is what I was just talking about. My apologies. So, service entrance conductors shall be permitted to be spliced or tapped in accordance with 110.14, 300.5e, 300.13, and 300.15. Power distribution blocks, pressure connectors, and devices for splices and taps shall be listed. Power distribution blocks installed on service conductors shall be marked suitable for use on the line side of service equipment or equivalent. Alright. Gonna keep going through this. 230.51 mounting supports. Service entrance cables or individual open service conductors shall be supported as specified. Service entrance cables shall be supported by straps or other approved means within 12 inch of every service head, gooseneck, or connection to a raceway or enclosure, and at intervals not exceeding 30 inches. Other cables. Cables that are not approved for mounting or in contact with a building or other structure shall be mounted on an insulated supports installed at intervals not exceeding 15 feet in a manner that maintains clearance of not less than 2 inch from the surface over which they pass. Raceways to drain where exposed to the weather. Raceways closing service conductors shall be listed or approved for use in wet locations and arranged to drain. Embedded in masonry, raceways shall be arranged to drain. Service head. Service raceways should be equipped with a service head at the point of connection to service drop or overhead service conductors. The service head shall be listed for use in wet locations. Service heads goosenecks above service drop or overhead service attachment. Service heads on raceways or service entrance cables and goosenecks in service entrance cables shall be located above the point of attachment of the service drop or overhead service conductors to the building or other surface or structure. Secured. Service entrance cables should be secured. Okay. Drip loops. Drip loops should be formed on individual conductors to prevent the entrance of moisture. Service entrance conductors shall be connected to the service drop or overhead service conductor either 1, below the level of the service head, or 2, below the level of the termination of the service entrance cable sheath. So, what does that mean? It means that you want a droop in your cable to allow water to shake off from the cable itself, because water cannot travel uphill nearly as well as it travels downhill. So the idea is essentially it'll drip off of the cable before it tries to enter the service itself. Okay. Service conductor with the higher voltage ground. On a 4-wire delta connected system or service where the midpoint of one phase winding is grounded, service conductor having a higher phase voltage to ground shall be durably and permanently marked by an outer finish that is orange in color or by other effective means at each termination or junction point. This is something that was also on the test. There was another code article way earlier in the book that I use personally, but that is also good to mark. Service equipment general. Service equipment enclosed or guarded. Energized parts of service equipment shall be enclosed as specified in 230.62a. Guarded as specified as 62b. Closed. Energized parts shall be enclosed so that they will not be exposed to accidental contact, shall be guarded as in 62b. Energized parts that are not enclosed shall be installed on the switchboard, panel board, or control board and guarded in accordance with 110.18 and 110.27. Energized parts are guarded as provided in 110.27a1 and a2. A means for locking or sealing doors providing access to energized parts shall be provided. Barriers. Barriers shall be placed in service equipment such that no uninsulated, ungrounded service bus bar or service terminal is exposed to inadvertent contact by persons or maintenance equipment while servicing low terminations while the service disconnects in the open position. Got it. Marking. Service equipment rated at 1,000 volts or less shall be marked to identify it as being suitable for use as service equipment. All service equipment shall be listed or field evaluated. Meter sockets. Meter sockets shall not be considered service equipment, but shall be listed and rated for the voltage and current rating of the service. Kind of obvious. Surge protection. Surge protect device. Same rules as previously stated. So, supplies these areas is in these locations. This type replacement if you do maintenance, or if you replacement if you do a renovation, I should say. And then 10 kiloamp discharge current. Disconnecting means 230.70 general. Means shall be provided to disconnect all ungrounded service conductors in a building or other structure from the service conductors. A. Location. Service disconnecting means shall be installed in accordance with a 1, 2, and 3 readily accessible location. The disconnecting service means shall be installed at a readily accessible location, either outside of a building or structure or inside nearest point of entrance of the service conductors. 2. Bathrooms. Service disconnecting means should not be installed in bathrooms. 3. We never highlighted, but I'm going to go over it anyways. Where a remote control device is used to actuate the service disconnecting means, the service disconnecting means shall be located in accordance with 230.70a, aka it needs to be readily accessible. B. Marking. Each service disconnect should be permanently marked to identify it. C. Suitable for use. Each service disconnecting means shall be suitable for the prevailing conditions. If it's in a hazardous location, it needs to be marked as hazmat, or needs to comply with hazardous location requirements. Maximum number of disconnect. Each service shall have only one disconnecting means unless the requirements of 71B are met. For the purpose of this section, disconnecting means installed as part of listed equipment and used solely for the following shall not be considered as service disconnecting means. 1. Powered monitoring equipment. 2. Circuit protected device. 3. Control circuit of the ground fault protection system. Or 4. Power operable service disconnecting means. B. 2 to 6 service disconnects. 2 to 6 service disconnects shall be permitted for each service permitted by 230.2 for each set of service entrance conductors permitted by 230.40. Exception number 1, 2, 3, 4, 5. The 2 to 6 service disconnecting means should be permitted to consist of a combination of any of the following: separate enclosures, panel boards for the main service, switchboards, blah, blah, blah. Basically, you cannot have more than 6 switches in a disconnecting means. Okay. Grouping of disconnects. The 2 to 6 disconnects, if permitted in 230.71, shall be grouped. Each disconnect shall be marked to indicate the load served. Additional service disconnecting means. The 1 or more additional service disconnecting means for fire pumps, emergency systems, etc., permitted by 230.2 should be installed remote from the 1 to 6 service disconnecting means for normal service. So don't put your emergency disconnect by your regular disconnect. Access to occupants. I gone over that. Simultaneous opening of poles. Each service disconnect shall simultaneously disconnect all ungrounded service conductors that it controls from the premises wiring system. No dip. Or no shit. Disconnection of ground conductor where the service disconnecting means does not disconnect the ground conductor from the premises wiring. No other means shall be provided for this purpose in the service equipment. So, or other means shall be provided for this purpose. So if your standard disconnect doesn't disconnect the grounded conductor, you have to have something else to do it. Back up here, indicating, it should indicate if it's on or off. Service rating of service disconnecting means shall be rated for these situations. Already went over those. Last couple things on this page. It's 230.85 emergency disconnects for 1 and 2 family dwelling units. An emergency disconnecting means shall be installed in a readily accessible outdoor location or within inside a dwelling unit. Proper rating, grouping, disconnects, replacement, identification, whatever. Marking. This is one that we did not go over, but is important because it was on the test. The disconnecting means shall be marked as follows: service disconnect, emergency disconnect, service disconnect, emergency disconnect, meter disconnect, not service equipment. So, pretty important, because if you have an emergency and you need to disconnect, you want to know what you need to disconnect specifically. So, alright. So, that's it for Articles 215, 225, and 230. I will be working on math and DC for the rest of the day until I finish up with those. So, hopefully you will see those as well this weekend. I will see you soon.